Hello everyone, you're welcome to today's class and I'll be talking on the concept of atoms, molecules and ions. Concept of atoms, molecules and ions. So these are the content that I'll be talking about today. I'll divide the atom, I will talk on molecules, ions. I will also talk on doubting atomic theory and the modifications of doubting atomic theory. Let's start with atom. Atom is the smallest particle of an element which can take part in a chemical reaction. You also know that atom is the smallest particle of an element that can take part in a chemical reaction. An atom is actually gotten from the Greek word atomos, which means indivisible. Indivisible. Actually, it was John Dalton that said that atom is the smallest indivisible part of an element. But I will still get there now. I will still get there. But just know that atom is the smallest particle of an element that can take place in a chemical reaction. Now, molecules. What are molecules? A molecule is the smallest particle of a substance that is capable of having independent existence and still retain the chemical properties of that substance, be it an element or a compound. It's the smallest particle of a substance that is capable of independent existence and still retain the chemical properties of that substance, be it an element or a compound. And a molecule is actually formed when two or more atoms are chemically joined together. A molecule is formed when two or more atoms are joined chemically together, and the combination of atoms of the same type of molecule of an element. An example is hydrogen molecule. So the symbol is H2. We also have oxygen molecule, nitrogen molecule, and chlorine molecule. All these elements that I mentioned now is that there's something you should know about them is that they exist as molecules. They exist as molecule. And then another example of different combination of type of atom are the sodium chloride, that is and sodium and chlorine ion. Then we also have the calcium chloride. So just know that a molecule is a substance form when two or more atoms are chemically joined together. Now I want to quickly talk about something that is important under molecules, and that is atomicity. And atomicity is the number of atoms in each molecule of an element. Is the number of atoms in each molecule of an element. So if you look at the table here if you look at neon, we see that neon has only one, it's just Ne, and the atomicity is 1, and sometimes we call it monoatomic. So we can say that neon is monoatomic. Argon 2 also is a monoatomic. But if you look at hydrogen, nitrogen, oxygen, and oxygen, we have H2, N2, O2. All these are diatomic, meaning two molecules joined together. They are diatomic. Ozone is triatomic. Phosphorus is tetraatomic, and sulfur is octatomic. And actually, a lot of time, anytime that the atomicity is more than 2, we can just call it polyatomic. So these are just things that will help us to understand molecule very well. So please don't forget this table. Now we move to ions. What is an ion? An ion is any atom or group of atoms that possess electric charge. Ion is any atom or group of atoms that possesses an electric charge. And ions are formed when elements either when they loses or gains an electron. Ions are formed when element loses or gain electron. When element loses an electron, a positively charged ion is formed, or cation. Another name for positively charged ion is cation. But when it gains an electron, a negatively charged ion or anion is formed. So we actually have two types of ion. We have the positively charged ion or the cation, and then we have the negatively charged ion or the anion. So don't forget, ions are formed when elements loses or gain electron. When they lose or gain electron, that is when we have ions. Now, so under the concept of atoms, molecules, and ion, I won't do a great justice if we do not talk about the Dalton atomic theory. And the Dalton atomic theory states as follows: that all elements are made up of small indivisible particles called atom. All elements are made up of small indivisible particles called atom. Then we have that atoms can neither be created nor destroyed. Then the third one, atoms of the same elements are alike in every aspect and differ from atoms of other elements. Then the fourth one, when atoms combine with other atoms, they do so in simple ratio. And actually, it was John Dalton that gave this theory in the 19th century. This theory was actually useful for a time, but there is now modification of Dalton atomic theory. So if you look at the first one, that the first modification, that all elements are made up of small indivisible particles called atom. But this statement has actually been proven wrong by Rutherford discovery. And we should know that atom is made up of three main types of particles, that is proton, neutron, and electron. Then the second modification to Dalton atomic theory, Dalton said that atom can neither be created nor destroyed. And this statement is actually true for ordinary chemical reaction. But nuclear reaction, now when we are talking about radioactivity, nuclear fusion, nuclear fission, has actually made us to understand that atoms can be destroyed. But this is actually true for ordinary chemical reaction. But when we get to radioactive reaction, that's another thing entirely. So this statement of Dalton is not that correct. It's not that correct anymore. Then the third one is that atoms of the same elements are alike in every aspect and differ from atoms of other elements. And this statement is actually wrong, because the discovery of isotopes make this statement unacceptable. What are isotopes? Isotopes are elements that have the same proton number but different neutron number. They have the same atomic number but they have different mass number. So this statement by Dalton is wrong due to the discovery of isotope. Then the fourth one is that when atoms combine with other atoms, they do so in simple ratio. And this statement is generally correct for inorganic compounds, because inorganic compound, they contains few atoms per molecule. But this is not true for organic compounds, because carbon form a very large organic compounds such as protein, fat, and starch, which contains thousands of atoms. So that statement is partially true. It is true for inorganic compound, but for organic compound it is not true, because organic compounds are able to form large molecules, very large molecules that contains thousands and thousands of atoms. So I will end there for today so that this video will not be too long. So by the grace of God, I will still continue. We'll continue with the lecture. So thank you for listening, and don't forget to like and subscribe. Have a wonderful day.